101.
Okay, perfect. Yeah, we can get started. Go ahead.
Great. Well, hello, everyone. Welcome to the first opening ceremony of the AI Research School. Hello. Hi, Dr. Joshi. How are you?
Hi, I'm good. How are you?
Good, good. Nice to meet you. We look forward to
Good.
hearing you speak later. So my name is Yu Zheng, and my co-program chair is Sebastian. If you want to say hi.
Hi.
And then we have Dr. Farhan Maliki, who you must know from this program if you're from University of Calgary. And we also have Dr. Saki Joshi, who will be a speaker of today. Is there anything else that you guys want to say before we get started with the program? No?
I guess you can start sharing your screen, Jean.
Yep. Okay. Alrighty, let's get started. Okay, so again, welcome. This is the opening ceremony, and today is February 25th, and we'll have a 2-month program to go. As I mentioned before, on the weekend, we'll always start at 10 a.m. Mountain Standard Time. Be mindful of the time zones because Sebastian and I are in Montreal and it's Eastern Standard Time. All right.
So first, we'd like to start by acknowledging the land we live on in Calgary. So the University of Calgary, located in the heart of southern Alberta, both acknowledges and pays tribute to the traditional territories of the peoples of Treaty 7, which include the Blackfoot Confederacy, comprised of the Siskaka and Piikani and the Kainai First Nation, the Tsuut'ina First Nation, and the Stoney Nakoda, including Chiniki, Bearspaw, and Goodstoney First Nation. The city of Calgary is also home to the Métis Nation of Alberta, Region 3. So now we will only be talking a bit about logistics and program overview with my colleague Eugene. Then Dr. Joshi will give a small talk about AI, and then Dr. Farhan Maliki will give a small talk about the vision of this AI research school.
Perfect. And a little bit of logistics right off the bat in terms of communications. You might have received our email from Eventbrite, where we have given you this Zoom link as well as the Discord link to join the Discord channel. That'll be the main way of communication. However, if you do like to send us email via the Gmail address, please go ahead as well at the airesearchschool@gmail.com. You will have reminder emails sent from Eventbrite before each session at different time points, and a Google Calendar of the entire session will be shared. In the email from yesterday, we have asked you to fill out a Google survey because this research school is partnered and supported by Google Research. So Sebastian, if you can send this Google survey link in the Zoom chat again, that would be wonderful. It doesn't take that much time for you guys to fill it, so please go ahead. Yep. I think he's still.
Yes.
Great.
Yeah, I just sent it.
Yep.
And then a few rules that we would like you to follow, because as of now, 100+ participants registered. So it's really important that you treat your fellow participant with respect. And also we'd like to you to use your real name on Zoom. And really important that you stay muted during the presentations, because sometimes, you know, without paying attention, you can unmute and it leads to background noise and it can disturb the speakers. So please remain muted. But if you can still ask questions during the presentations, but just make sure you enter them in the chat, and we will have dedicated Q&A time at the end if you want to unmute to ask a specific question.
Yeah, absolutely. And if you have we've seen that a number of you have joined the Discord channel already, which is fantastic. And you'll see a few different text channels in there. In the general channel, that's where we will post, I guess, some logistic questions if you have anything. And then in the workshops, we will talk about the schedules later on. And we have multiple workshops a week. We also have career talks like the one that we're having today with Dr. Joshi. We also have frequently asked questions channel, where sometimes if we get some of the emails whose answer may benefit a lot of you, we'll rephrase the email question and post it there. And you can feel free to ask as well. Great.
So now we're really happy to introduce our steering committee. So it's made first of Dr. Farhad Maliki, who is an assistant professor in the computer science department at the University of Calgary, where his main research areas focus on artificial intelligence and computer vision. He's a member of the Hotchkiss Brain Institute and adjunct faculty member at McGill University and the University of Florida. And currently, Dr. Maliki is a member of the Machine Learning Education Subcommittee of the Society of Imaging Informatics in Medicine. Then we have Dr. Katie Ovens, which is an assistant professor in fundamental data science at the University of Calgary as well, in the computer science department. Her research is mainly focused on data science for the large-scale analysis of imaging data in the biological and medical domains for the creation of new insights into how to combat disease and illness. And this includes developing machine learning strategies for combining omics data with medical imaging features and utilizing computer vision techniques to more easily and effectively gain insight from biological and medical images. So both experts in artificial intelligence and organizing this AI research school with all of us.
Absolutely. Thank you, Sebastian. And secondly, and very importantly, we would like to acknowledge and thank our student leadership team from University of Calgary. We're also Dr. Maliki's students right now, and they're made up of master student and research assistant in the lab. First, we have Arif Matamedi, who is a communication and media chair, and we also have Hussein Beheshti Fard, who is also a communication media chair. We have now Shiva Haydari, who is the local chair, and Shakufa Gaz, who is the EDI chair. Each of them have contributed significantly in terms of finding people of various channels in the University of Calgary to contact and advertising the event, and last but not least, making the website for the AI Research School, which you may have seen before. So thank you very much. Let's move on to the next.
So now it's time to introduce ourselves more properly. So it's my pleasure to introduce my colleague, Eugene Zhu, which is program chair for this AI Research School. She's currently a PhD student in the biological and biomedical department, engineering department of McGill University. And she's also working closely with the Department of Computer Science with Dr. Maliki at the University of Calgary. She is working on developing multi-modality treatment outcome prediction using deep learning and data analysis tools.
Thank you very much, Sebastian. And now it's my pleasure to introduce Sebastian Kiten, who is my co-program chair, also studying at the PhD in the Biomedical and Biological Engineering program and Medical Physics unit at McGill University, working with Dr. Anger, as well as closely with Dr. Farhad Maliki at the Department of Computer Science and University of Calgary as well, where he is working on deep learning-based brachytherapy treatment planning, as well as we're both on a self-supervised learning project in medical image analysis with Dr. Maliki as well. Great.
So now a bit of timeline of this research school. So during phase 1, you will attend workshops and career talks. We will go through basics of machine learning and classical machine learning, and move towards deep learning and its application to computer vision. And then selected students will be able to apply what they have learned during a research project.
Yeah, and then the phase 2 for the hands-on research part, we will leave it to Dr. Maliki to talk to you more about it at the end of this closing ceremony, opening ceremony. Great, and here is the AI school research school schedule that you may have seen before as well from the website. So it's for phase 1, it'll be from week 0. Well, week 1 from week to week 4, where we will take you from machine learning methods all the way up to semantic segmentation. And in between, as mentioned before, we'll have career talks. Most of these workshops will take place on the weekends, on the Saturday and the Sunday. And the career talks, we have 3 of them differently, including today. There'll be 4 on Wednesdays. And do be mindful, do pay attention, as I mentioned before, of your time zone. Time zone is the Mountain Standard Time. And at the end of the phase 1, we'll have selected students to participate in the phase 2, which is the research project. So do work hard and join us for the research phase as well.
A bit of requirements for this AI Research School. So the way the workshop will be held is with Google Colab notebooks, because they are tools that are very easy to use and freely available. So please create a Gmail account if you don't already have one. And then once you have this Google account, it's really easy to access the Google Colab notebooks. It's just through a link. So we will be sharing all the Google Colab notebooks before the workshops, so that if you want, you can run the piece of code. It will be Python code. If you want, you can run this code at the same time as the workshop is happening to play around with the code, and it might raise up some question that you can ask during the workshop as well. And something else, please make sure that you always use the same Zoom account when you log into the sessions. Yeah, it's really important for us to track like people who are attending. And yeah, we also encourage you to participate as much as you can, because it will be important for you to be selected to go to the second phase, which is like the research project.
Yeah, thank you very much, Sebastian. And now we move on to the second portion of the opening ceremony, which is it's my pleasure to introduce our speaker, Dr. Saki Joshi, who is a senior engineer in natural language understanding at Google Research with a master's degree from Oregon State University and PhD from Tufts University. Dr. Joshi has been a researcher and practitioner of AI/ML for the last 20 years. His work includes building inference capabilities for large-scale knowledge bases and natural language capabilities for voice assistants. And currently, he is working at Google Research, building ML for health and safety applications. So take it away. Thank you very much. I'm going to stop sharing my screen now. Great.
Thank you, Eugene, and thank you, Sebastian. Well, hi, folks. Firstly, I want to thank Farhad for making me a part of this workshop. It brings me back to my days in academia, which I really cherish, although it has been a while since then. In fact, it has been so long that, like some old people, I can legitimately say, back in the day when we were students, things used to be different. But these days, that's not saying a lot. The field of AI and machine learning is actually evolving so fast that even folks who graduated 5 years ago can say the same thing, and they won't actually be wrong. Right? AI is not a new field by any means. In fact, one can argue that AI as a discipline has been in the making ever since the Greek mathematician Euclid published his work on the elements. Elements, it's basically a treatise about geometry, but it did introduce a key idea into mathematics. The idea was that of an axiomatic system of deduction. So what Euclid realized was that if you set down just a few basic propositions as known facts, then you can use the rules of logical deduction to infer a vast number of new facts. Now, these basic propositions are known as axioms, and Euclid's system, his original system in elements, it had only 9 axioms, and he was able to derive a huge number of theorems in geometry with this technique. And today we take this system of proof for granted, but it was new at that time. And this key idea of axioms and deduction was so powerful that it got adopted into all branches of mathematics, including number theory, which is like the core of math, right? Now, from Euclid, let's fast forward to the 19th century. Not much happened in the interim, but slowly progress was being made. And in the 19th century, mathematicians started wondering, well, if all it takes to prove mathematical theorems is to start from some axioms and apply some rules. Why can't a machine do it? Well, the question got widespread acceptance when the British mathematician named David Hilbert posed this as one of the top challenges to the mathematicians of the next century, the 20th century. And within the next decade, the philosopher Bertrand Russell, the famous Bertrand Russell, he wrote a book called Principia Mathematica, in which he basically came up with this system of rules that used axioms and deductions, and his system could solve all of number theory using only axioms and deductions. So he basically said, yes, we can do it. And obviously the book became a rage. It was like the Chat GPT of its time, right? It suddenly caught on fire, quite a sensation. And people started thinking, if machines can really prove all mathematical theorems, can it do more? Well, once math is conquered, then the sciences are next. So physics, chemistry, biology, and then why not art and music? Well, art and music seem a strange thing for a machine to do. At least at that time, it seemed really impossible. But if you think about it, when reduced down to theory, art and music also follow the rules of mathematics. So can a machine do math, discover new compounds, play the piano, dance the waltz, and draw a painting while solving the riddles of the universe? Well, and even if it can do some of those things, what's there to separate it from a human then? Could such a machine be intelligent? That was the real question, right? And it was the word intelligent that broke the proverbial camel's back. You see, at that time, similar to the way it is today, there were many voices who were warning against artificial intelligence. Now, this camp who was against artificial intelligence felt that machines either could not or should not become intelligent. There were many arguments against AI. There were biological arguments, religious arguments, philosophical arguments, as you can imagine. But these arguments were more of an emotional appeal, and they weren't going to deter the mathematicians. This anti-AI camp actually got their first victory about 20 years after Bertrand Russell's claim that machines can solve all of mathematics. And this victory for the anti-AI camp came from an Austrian mathematician called Kurt Gödel. And Gödel proved that the system of Bertrand Russell, the Principia Mathematica, which was supposed to solve all of mathematics, could basically, not solve all of mathematics. Right? And that was for a very simple reason. The reason was that in number theory, one could always pose a statement such that by attempting to prove or disprove that statement, the system would contradict itself. To put it in layman's terms, rather in terms that a person like me can understand, like consider the sentence, I am lying, right? Now let's try to derive whether I'm being truthful or untruthful over here. Well, if I am being truthful, then I am indeed lying, which means I am being untruthful. And if I am being untruthful, then I must be telling the truth because I just told you that I am lying, right? So you see that in trying to ascertain the validity of the statement, we run into a contradiction, right? This, but in mathematical terms, was what Gödel discovered. And as if it wasn't enough, Gödel's blow was followed by the British mathematician Alan Turing coming to the same conclusion with his Turing machine. The Turing machine is a mathematical model for all computers that are in existence today. And Turing's version of this was called the halting problem, which basically said that you cannot build a computer that can reliably tell if an arbitrary program will or will not go into an infinite loop on a given input, right? So essentially, Bertrand Russell said, yes, we can solve all of math using machines. Gödel and Turing said, no, we cannot. And now, along with this religious, biological, and philosophical arguments to AI, there was a mathematical argument against AI. If computers cannot solve all of mathematics, then obviously we can forget the rest, right? No physics, no music, and nothing, right? Computers cannot become intelligent. And that is the end of AI, end of story. But of course, that was not the end of story. Otherwise, we wouldn't be meeting here today, right? And it was Alan Turing who actually came to the rescue. In 1950, he wrote a beautiful paper called Computing Machinery and Intelligence. And if you haven't read that paper, please Google it and read it. It's extremely readable. It's not math heavy. It's very readable. Now, in that paper, he argued that the opponents of AI are basically setting the bar too high. After all, humans had 2 millennia after Euclid to discover all of mathematics, and they didn't do it. Yet humans are thought of as intelligent, right? So why the double standard? So Turing came up with a famous test as a bar for artificial intelligence. It's called the Turing test. The idea was for an impartial judge to interact with a human and a computer at the same time. And if the judge could not tell which is the human and which is the computer, then the computer must be declared intelligent. And this was Turing's genius move to save AI by reducing the question of intelligence to intelligent behavior. Right? No one then had, at that time, no one had to prove that a computer was philosophically or biologically equal to a human. All they needed to do was to create a machine that could replicate human behavior. This gave mathematicians and computer scientists a scientific target to shoot for. And in just the next 6 years, the first AI conference was held in Dartmouth College in New Hampshire. And this gave rise to the new AI researcher. Right? All the luminaries, John McCarthy, Marvin Minsky, Claude Shannon, all of those were there at that conference. And right from the start, AI research was divided into two camps, right? And there was some sort of a rivalry between them, obviously. Now, in one camp, there were the logicians who believed in the old axiomatic system of Euclid, right? The AIs that they built were made up of rules. So the system was basically a rule-based system. So you provide an input to the system that would fire some rules. Those would fire some more rules. Those would fire some more rules, and out would come an output. Right? And that output would look like something that a human derived from the input. But these rules were largely handcrafted by the researchers. In the 1980s, such AIs were known as expert systems, and they were very popular. In fact, there was a belief that by the 1990s, expert systems would create the first true artificial intelligence that would pass the Turing test. The people in the 80s really believed that. Obviously, that did not happen, but it did. This effort, this line of research did give rise to some really cool programs, like Deep Blue, the Deep Blue computer that defeated Garry Kasparov. That really came from many of the ideas of rule-based systems. The other camp, which now we are more interested in, consisted of information theorists and statisticians. Right? Their strategy was different. It was based on the idea that programs that truly exhibited intelligent behavior would be so complex that human programmers would not be able to write them. Right? It's really hard to say ask somebody, tell me how you recognize a face and I'll encode it as a program. Right? We can't do that. Instead, such programs should be reverse engineered from data sets of input-output pairs. Right? This was the birth of statistical machine learning. And machine learning became very popular in the 1990s after expert systems, which by then were termed as good old-fashioned AI. They could not live up to the promise of passing the Turing test. But the 90s and 2000s saw plenty of research in both camps, including very big efforts to bring the best ideas of the both camps together in a newly minted field called statistical logic. Then came 2012, when an old but largely overlooked statistical learning model, it came seemingly out of nowhere and kicked the butt of every other technique in the field. This model was known as a neural network, right? And in particular, a variant called deep neural network. And the next year, deep neural networks, or deep learning models as they are now called, kicked the butt in the field of natural language processing. And that trend over the last 10 years has led us directly to large language models like ChatGPT, right? Which is the absolute cutting edge of AI technology today. Now, some people believe large language models will lead to the first true AI. Some extremely prominent thinkers believe that they won't. After all, we almost but never quite achieved AI with expert systems, right? Why should we believe that this time there is something different? Could LLMs actually achieve AI, or will they be a dead end? Well, who knows? Perhaps statistical logic or expert systems even will make a comeback like neural networks once did. The jury is still out on that, but what we do know is AI is the biggest and fastest growing technology today. And machine learning is the best tool we have for furthering the boundaries of AI. Now, that is why I'm really excited to be part of this workshop, because this workshop is going to give rise to a new wave of AI researchers and practitioners. And who knows, one of you could be the one who finally finishes something that Euclid started 2 millennia ago. With that, I wish you all the best. Thank you.
Thank you so much, Dr. Joshi. That was super insightful, super interesting. I wanna continue hearing you speak about the topic right now. Thank you very much. Does anyone have any question for Dr. Joshi? Feel free to unmute yourself and ask it if you have. Okay. I guess maybe
I think there are
students
some questions on the chat.
Oh, okay. I'm gonna read them out loud now. So it's thanking you all the way. That was amazing. Oh, what was the paper by Turing you recommended?
Oh yeah, I just wrote it. It's computing machinery and intelligence.
Yeah,
I just wrote
okay.
it in the chat.
That's great. Oh, and someone sent a PDF. That's great. Could you explain what is a neural network?
Oh, what a neural network actually is?
Yeah, that's a question in the chat.
Yeah, it originally started as just replicating what we do in our brains, right? The whole idea was, well, if we want to create intelligence, we already know something that is intelligent. Let's try to copy that, right? And it started with really small neural networks, like single node networks called perceptrons, which are basically just matrix multiplications, right? So you can just take a vector of inputs, multiply a matrix to it, and generate an output, right? So you basically map your input from one space to another space. And it was Marvin Minsky who showed that this won't actually work, right, for building very large systems, because a single perceptron cannot even solve problems like XOR, right? So if you take an XOR function, a perceptron cannot really express an XOR function. So it obviously can't do much more than that. So then people came up with larger neural networks that weren't limited to single neurons, right? They stack neurons one on top of the other, which basically means now you do one matrix multiplication followed by some nonlinear transformation followed by some other matrix multiplication, right? Now this puts your input into a completely different space from the original space that your single neuron could not have done, right? And this process can keep continuing, right? You can do this many times. That is really what a neural network is. The surprising thing about neural networks was people didn't really know how to train them until the 80s, right? I mean, these perceptron and Minsky's proofs that I'm talking about, these are like in the late 60s. But it was until in 80s that I think it was Rosenblatt and Jeffrey Hinton who came up with the backpropagation algorithm, which we still use today for training neural networks. So, long story short, probably a big answer to a small question, but neural networks are a model. They are a Turing complete model, right? So you can actually generate any program that you want in the world. Anything that is doable by a computer is representable by a Turing by a neural network, right? The idea is to build these neural networks by statistical methods, by looking at data and reverse engineering them. And it is the best model for machine learning that we have today. But who knows, things might change.
And that is also why we want to learn about it during this AI research call. Thank you very much, Dr. Joshi. We have another questions from Valerie Kim. Weren't cyberneticians involved in the early connectionist camp as well?
Well, sorry, can you repeat that? Oh,
yeah,
cyberneticians.
Cyberneticians involved in the early connectionist camp as well?
I'm not sure if I can answer that. depends on what you mean by cyberneticians. I think that word has multiple definitions, if I understand correctly.
Okay, Valerie, if you want to elaborate, you can precise on the chat. We have another question by Farzan Afshar. Is that right that the article of neural network was old, but the application of that was show up years later?
Yes, neural networks were invented quite a while ago. In fact, in the 50s. They came into a little bit of prominence in the 60s because we had some nice perceptron algorithms to work with them. But then there was a big blow, and by the time we actually knew how to train neural network, it was the 80s. So the research has followed quite a trajectory, and then people lost faith in neural networks for a long time until like 2006 and 2012. And it was largely people like Jeffrey Hinton, basically, who pulled everyone through that slump in belief in the neural networks. But here we are today, and he rightly has the Turing Award for that.
Thank you very much. So Valerie precised on the chat, she said cybernetic as in the 1945-55 Massey conventions. Massey conventions.
Oh,
I'm not sure.
Conventions. I'm not familiar with that, sorry.
Okay, no problem. Thank you very much. How do we know, there's another question by Faris. How do we know that a machine's intelligence is not just limitation of humans? Will it need to have consciousness?
So, good question. That is more of a philosophical question. Mainly, we don't really know what consciousness is, just as we don't actually know what intelligence is. But after Turing's paper, AI researchers gave up the problem of consciousness altogether. Right? If you are interested in the field of consciousness, then that belongs to the realm of philosophical research today, more than AI research. But AI research, because of Turing, has now been boiled down to just intelligent behavior, passing the Turing test. Right? Whether it requires consciousness to pass the Turing test and what consciousness is are questions that most AI researchers have pushed to the sidelines. And maybe if we have intelligence one day, we might come back to those questions. But I don't see it in the near future.
Thank you very much. We have two more questions. One from Mohammed. What is the difference between machine learning and deep learning?
Deep learning is machine learning. It is just a newer form of machine learning. So machine learning includes a lot of things, right? Machine learning is basically the idea that you can reverse engineer a computer program by looking at the input and the output, right? That is machine learning, and doing it with a computer itself is machine learning, right? And in the field of machine learning, there are many different models that people came up with. And the history of machine learning has a lot of those. Like, people don't even talk about decision trees anymore, right? People don't talk about support vector machines anymore. These models were big rages, big things at one time. Neural network is just one of those models, but people realize that by increasing the depth of neural networks, you can actually build really cool and complicated models, and that is deep learning, right? So deep learning is a subfield of machine learning, in short.
Thank you very much. There is a question by Farzan. Are we going to involve forward of Geoffrey Hinton on this workshop? So Farzan, maybe I can answer that for you. So during the workshop, we will cover deep learning fundamentals, but maybe not on this very first opening ceremony. We have another question for you, Dr. Joshi, from Anna. Can you unblack a black box obtained from machine learning?
So there are, I mean, when you say machine learning, you're actually putting too many things in the same box. Machine learning models come in various shapes and sizes, and some of them are not really as black boxes as neural networks are. Today, we look at neural networks and we say, okay, all of machine learning is black box. That's not true. In fact, the rule-based systems, the expert systems that I talked about, they were specifically not black boxes. You could trace exactly why a particular decision was made by tracing the rules that fired. Right? Neural networks are black boxes, unfortunately, and there's a whole body of work on interpretable neural networks that is trying to unblack them. But it's still in nascent stages. We have some understanding of what it means to unblack a neural network, and we are working on it.
Thank you so much. So I think your talk have raised a lot of questions. So maybe we will allow just one last one. So there's a question from Ivan. I've read in a textbook about deep learning that neural networks double in size roughly every 2.5 years. Do you believe intelligence would emerge in a model once it passes or matches a human brain in size?
I really don't know. This is it's a if that is if that does happen, then we are far from it right now. The human brain has like 100 billion cells or something like that, and no, it's far more than that, I believe, right? And the largest models that we have are about 175 billion parameters. So, and we don't even know if one cell is the same as one parameter, right? One cell is probably more than that, because a cell itself can perform functions that a single parameter cannot. So we are far from reaching the size of a human brain. I also hope that it doesn't continue the same trajectory of power usage that we have. If we really were to power a single brain on the way we power neural networks today, we'll be in a real energy crisis.
Okay. Thank you so much, Dr. Joshi, for all these answers. And we're very glad to have you here today to talk about this topic, because yeah, it's the main topic of this call. So thank you very much.
Thank you. It's my pleasure.
Thank you. Now I think we can move on to our program director, which is going to present more in details the program and the vision of this AI research school. Dr. Maliki, please go ahead.
Thank you, Sebastian, and thank you, Dr. Joshi, for the great presentation, actually. One reason, actually, that we decided to have this event is to answer these questions. As Dr. Joshi said, there are huge investments from different groups, different intellectual parties in expanding the knowledge in AI. And the students actually should be in front of this knowledge gaining, dissemination, and it is the main reason actually we decided to have this initiative here. And many people will be helping us through this process, people from different backgrounds and disciplines. And that's also show how diverse the techniques and the possibility and opportunity that you can get from AI actually as a student will be. To start with, perhaps some of you have asked yourself why I should sign up for this event. And when designing this program, actually, we've thought about that, why students need to show up in such a program and how we can actually tailor the program in order to better answer those needs or those questions, actually. Perhaps most of you have read with different cool applications, tools, and innovation companies that are AI-based, research in academia or industry that's come up with very interesting, creative solution for things that in the past, like perhaps when I say in the past, maybe 10 years ago or even 5 years ago, people didn't feel it is possible to achieve it. And now it is achievable. We see the starting of a revolution in, it's not just in computer science. This is something that affects many, many different areas of science and engineering in general. And won't be limited to just science and engineering. Now, research in different area or application in different area that in the past used to be qualitative, now quickly moved to being quantitative, because now we have systems AI-based systems that actually can interpret or analyze complex and unstructured data set. In the past, it wasn't easy to process a video. It wasn't easy to process, let's say, human behavior in a way that's, or not just human. Imagine you want to monitor the behavior of a fish after being exposed to a climate change or some disturbance in the environment. How we can, study that these days is quantitative, and we can do this. So AI brings a lot of opportunity for us. You know that perhaps there are high demand for AI, and among our students, the one that are most successful in job markets, and sometimes I have seen firsthand because of high demand, because of the skills that actually will be a competitive edge, a competitive advantage for a student with AI knowledge. They find jobs sometimes with a salary which is double the salary of a regular ComSci job, as let's say a software developer or a front end or back end designer. So these techniques actually contribute to your success in your career, helping you to find better job, helping you to participate in very cool projects and industries. Is AI limited to ComSci related companies? Absolutely not. There are a large number of companies across the board, different domains, different expertise. They are looking for AI experts because they have challenging problems to solve, and AI is a tool that can help you to decipher the data and perhaps come up with efficient and high quality solution for those problems. So you will see that AI will bring opportunity not only in computer science, but in many other area and discipline for you. Many of you might have great ideas, some cool app you want to build. Perhaps you have a dream of being an entrepreneur. AI actually bring many entrepreneurial opportunity for you as well. So that's something I really like you to have in mind. For the second phase of this program, that's some of you might be interested to join. For those, we have actually opportunity to define some projects. Students who come with their own project and they want to share, work on that, we'll try to help them with building a team and adding expertise and supervision for those students to work on something they feel it's cool, something that might be an app, something that you might even have in mind to commercialize it down the road. So those are great opportunity. And this skill and the way that you gain and expand your current knowledge actually open up many windows of collaboration and work with others. Currently, we are working to open up some opportunity for students who do well in the program. First of all, to be introduced to other researchers that are looking for intern and part-time experts with some background in ComSci and some background in AI. So those would be opportunities we want to provide for a student who do well in the program. For the second phase of the program, we'll have, first of all, first phase and second phase are different and they have different certificates. So some of you might just be interested in first phase and some of you might be interested actually to participate in both phase. So that's an option, you have both. For people who do well in the second phase, and first of all, we try to give you an opportunity to showcase your research in a local poster presentation. Some of you might have actually a result that is presentable in conferences. We try to support all of the students with those level of, let's say, work to be able to present their work elsewhere as well. So those are two opportunities. We are negotiating with some parties to see if we can actually open up some summer internship position for students who do well in the second phase as well. That's something that we'll find out. We'll have some initial support for that, but we are working hard to actually increase the number of those possibilities for students. And above all of these things, above all of the opportunities that AI will bring, I want to highlight something. Learning AI is fun and engaging. We all have a great joy when we create something, and AI helps you to create things that it wasn't possible 10 years ago. And you will see perhaps down the line, a few years down the line, you will see things that even now some experts say perhaps not possible. So the fact that a discipline is growing and advancing so fast means that many opportunities actually are hiding behind the corner. So around the corner, you find those opportunities that might be actually something that change your career. Some of you might actually shift your career in academia or some to industry, but AI might be the core that's direct those change. That's something I really like to encourage everyone to benefit from the program. We have a wonderful group of instructors and speakers from Google, from other companies, from different universities, and these are people who actually in the day-to-day life, they use AI, they benefit AI, and they build model, and they come up with experience in building larger scale models. Those opportunities are great. Please make sure to attend all of those sessions. Overall, AI will be an area that benefits a lot to academia. Academia actually is trying hard to keep up with the advances in AI, but as you can guess from a number of courses and different options that you have for courses that you can take, academia is really slow and behind always. One of the reasons that we have such an initiative is to help academia to actually improve that. Our mission for AI Research School actually is to train those interested in using AI to address challenges in various areas of science and engineering in general, and for both academia and industry. And how we deliver this through open, online, and free instruction and mentorship. That's unfortunately, it is not easy to have access to these, let's say, mentorship for students in general way. So this is once again an opportunity for you to actually benefit for this, expand your network. People that you meet through the program might be people who down the road introduce you to job opportunity, introduce you to interesting projects. And hopefully through this program and initiative like this, we'll be able to prepare a generation of researchers and practitioners who lead AI research and its application across a different discipline. Thank you, and back to you, Sebastian.
Thank you very much, Dr. Maliki. I think Eugene will have the closing word.
Thank you so much, Dr. Maliki. And that was a wonderful talk that you give, Dr. Joshi and Dr. Maliki. So I think we're at the end of this opening ceremony, and I'll just have a few reminders for what's coming. Today's the opening ceremony, and the first session will come up tomorrow, which is the workshop. And I have sent the link for the website if you haven't seen it. Tomorrow, also at 10 MST, I'm just going to share my screen again. So this is the website. So we're here today, and then on the Sunday we will have machine learning methods, the very first introduction. It's going to be a practical workshop with Google Colab and everything. So do prepare your Google accounts ready, and then we will share the content with you shortly. Is there anything else that we want to mention? Oh yeah, and then Dr. Joshi, you can hear more about his career and his journey in AI in the future career talk as well. Yeah, is there anything else? Is the workshop also on an hour? It's gonna be 1 hour to 1 hour and a half. We're gonna contain everything in our best abilities to make it below 90 minutes. Yeah, so that's gonna be the case. Will the recording be posted? Yes. So we have a YouTube channel, and we are going to upload all of these videos on the YouTube channel, and we'll share with you guys the YouTube channel link in future emails. So in a future email, you'll receive the Google Calendar link. You can download it and put it in your calendar, as well as the YouTube channel link. Yeah, anything else, Farhad and Sebastian?
Nothing from my side. Is there any, if any of the students have any questions, please feel free to unmute and ask, or just post in the chats.
Yep. If we're unable to make the live meeting but watch the recording, is our attendance still tracked? That's one of the questions. Is the first part of the school assignment based? How do you gauge whether a student is selected for part 2 of the school? Yeah, Fred, would you like to talk a little more about the active participation part?
Yeah, so active participation, first of all, it's active participation has 2 words, participation and activeness. Yeah, so being active means actually engage with students we have a Discord channel. Please, everyone, sign up there. That's a great opportunity to actually be active, show how you are active by helping others, by sharing information, by answering other people's questions. Those are perfect measure that we look for participation, activeness in participation during the session. Also, your activity is something we can see. Please, once again, it's an opportunity. Your activity and how you are engaged actually help both you and other people in this program to learn better and have a better experience. So that's in a nutshell, my answer.
Yeah, and can you explain what the intern opportunities are in both phases? Do we need to have a personal project for phase 2, or we can work on existing projects? I think the idea is that if you have an idea, you can bring it to the project. If not, and you're still selected, we can work something out. We have mentors, and Dr. Maliki will be involved as well to help you along the way. Yeah.
Yes. So for those of you who might be interested and excited about something, a project, let's say an app, something that we want to make it AI focused, for those down the road, you can bring that up, and we check our experts, or we try to have a group of mentors assigned for different. So you will be for the first phase, of course. It will be lecture based. It will be tutorial based. You feel free to work together in small group. But for the second phase, the students will be focused on a specific project. A small group of students. You will have a mentor. This mentor might be from industry or from academia. We try to assign mentors based on your project, as well as the expertise that require for that project. Some of them might require expertise that's some of us or some of our mentors actually are better suited for those projects. For a project that you we try to see if, first of all, they are feasible to complete or finish or partially finish during the during the program. Also, if we have access or you have access to data to train these models, so those are things we will work with you. We have also, we will down the road, we'll post a series of projects, and you can say, I am interested in this project or that project, and based on the students' preference, we try to accommodate those preferences and assign a student to different projects. Those are things that I can answer, and hopefully that answers the questions you have.
How many students will be selected for phase 2?
For phase 2, we try to have so active those who actively participate. Those all of them will be. We try to accommodate all of them. So that's my answer. I think there was an answer about scholarship, the internship opportunity as well. That's something we are working with. We have so far we have 2 confirmed internship position for summer, but we are working to expand that and hopefully get more opportunity for people who complete phase 2, of course, phase 1 and phase 2, and they are active. The way that these will be offered is through people who do really well as a subset of these, a student for, of course, there might be project-based. For example, if you work on a project analyzing, movie or sequential data, we might have a researcher that's asked for someone who is actually who has this skill. So in that case, we suggest people or students with those kind of project or those kind of skills. You will be interviewed by that research group, and one of you, for example, will be perhaps if there's one position, one of you might be accepted by that research group. For those internship positions, they will be paid positions. So it's like other research internship position that you might get through, let's say, USRA or a pure program. These are, if you don't know what these programs are, please make sure to search for them. These are internship opportunity for undergrad students. However, the deadline for this year has passed, but next year, I encourage all of you that are here next year and still a student and not graduated, consider that for actually for internship to apply for them, and definitely highlight your knowledge and your skill that you gained through this program, because that will be a huge factor helping you to be selected for those internships as well.
Perfect. And yeah, there is a main question about whether attendance can be made up by watching recordings. I think we will have more details on this question in the next session after we discuss internally a little bit. Is there any standout research or projects happening in Calgary that you might want to comment on? By Brody.
Can you repeat the question, please?
Is there any standout AI research or projects happening in Calgary that you might want to comment on?
So AI research and projects are active everywhere, actually. So both in academia and industry, we have great initiative working on AI research in different domains, and some of our speakers actually highlight some of those initiative and projects.
Yeah, perfect. I think this is perfect timing, and thank you very much, everyone, for coming today, and we'll see you tomorrow at the same time, and we'll have our first practical workshop on machine learning methods. Yeah.
Perfect. Thank you.
Thank you.
Thank you, everyone, and see you tomorrow.
Yeah. I'm going to close the meeting and then upload a recording. Bye.